So today's class would be on molecular electrostatic potential analysis, and for this analysis we make use of the checkpoints file. So I've already told you in previous videos how your checkpoint file is generated from your log file or your output file. So we're going to make use of the checkpoint file, which is here, this one. So I think I should make use of a smaller compound that has more polarity so that we can actually see what I'm talking about. So I think I need to find something with a checkpoint file. So let's find it. So check my archives. Okay, so we have some compounds here. So we're going to make use of this checkpoint file. Artemether, we know artemether, malaria drug. So you're going to open your checkpoint file in gas view. So now your checkpoint file is open. To carry out the molecular electrostatic potential analysis, you are going to, this thing is taking so much time. Just wait. Okay, so this is our artemeter. We're going to click on results, summary, and under results you're going to surface and contours, select it. So under surface and contours you're going to select cube action and new cube. We change this to total density. We're not changing any other thing, and okay. So we hold on. You can see that there's a calculation going on here. This is the calculation going on. So when this is done, it's going to disappear. So you have to wait. The analysis takes a lot of time and it's very slow. Now waiting. So now it's done, and then we have the new mapped surface under surface actions. That's what you're going to select. Then you're generating an electrostatic potential surface, so you select ESP, the molecular electrostatic potential, so ESP, and you press OK. So you see that a color code is coming out here, which means our ESP surface is beginning to generate, but we still have this running here, so you have to wait for it to finish. So you see, once it's done, it's going to generate your ESP surface. Now the next thing we're going to do is to edit our ESP surface. So let's enlarge this, and then we could move this aside. Move this aside. So now right click on your image, right click on it, and then you go to view. Under view, select display format. So when display format shows, you make sure you change the background color from blue to white. After changing the background color, you select the bond labels, the bond symbols, then you go to surface. You change the format to a transparent format so you can see the atoms that are involved in this electrostatic potential analysis. So you can increase your transparency or make it opaque. Then you have everything set up, I guess. So after this, you press OK. So now that you have this, how do we interpret the molecular electrostatic potential analysis? So you can see that we have regions that are blue. You see that we have a map at the top that shows a range from red to yellow to green to light sky blue to deep blue. Yes, so this is actually information that is interpreted using this picture. So now we're going to take an image of this picture. You can use a snipping tool and take this image. So you take this image, you copy it, and you put it in your manuscript. put it in your manuscript. You just paste it. Make sure you add the name of the compound below for description. Yes, when you are arranging your work. Now, how do I interpret this plot? Interpreting this plot now is you telling someone what information does this plot give when I'm asked like what can I tell somebody about this molecular electrostatic potential plot. So the red isosurfaces represent what we call electron-rich regions or nucleophilic regions. So you can see that the regions that are close to the oxygen atom, now you need your basic chemistry. Regions closer to the oxygen atoms happen to show you this red color. Yeah, they show you this red color, and this red color signifies electron-rich regions. While you see the region with blue, and the blue is not really light, it's not really dark blue, so it means that these regions are electron deficient or electron poor. So these regions would want to attract electrons to themselves, and these regions want to like give out, take part in reactions with electron deficient materials. So that's just the concept of the molecular electrostatic potential analysis. So you have to find a way to put your discussion, make it scientific when writing your manuscript.